Hello everyone, welcome back to the lecture series of Learning Theory of Automata and Formal Languages. My name is Binayak Parashar. I am working as an assistant professor in the Department of Computer Science and Engineering at Ajay Kumar Garg Engineering College. So till now we have successfully completed unit number 1 and we have tried to cover up all the basic concepts related to finite automata, where we have seen that how the finite automata is segregated into two parts, with output and without output. So in the without output part, we have seen the concept of DFA, we have seen the concept of NFA. This is nothing but deterministic finite automata, non-deterministic finite automata. We have seen how we can design a finite automata with empty transitions, okay, that is known as NFA with epsilon transitions. We have tried to see what is the equivalence property of all these machines, how we can convert each other, okay. Then we have seen the concept of finite automata with output about Murray and Mealy machines. Okay, so if students you have not gone through my previous videos and this is your first video, I would request you to go through the previous videos because you will not be able to relate what is going on in this particular unit. So basically in this lecture, that is lecture number 12, we will be going to start off with unit number 2, or you can say section number B, where we will be covering the concept of regular expression and regular language. Okay. So let's check today's agenda of the video, and today's agenda is regular expressions and its definition. Okay, so basically we have tried to see till now the concept of finite automata. We have tried to see the concept of automata. Okay, but how to represent a particular automata, we will be looking into this particular unit. Okay, and here we will try to analyze first how the language that is known as regular language, which is being accepted by this machine, can be divided into three categories. And that three categories we need to first analyze, we need to first understand, and then only we will be coming across with this expression. Okay, so let's check it out what and all topics we are going to cover one by one. And this is our first topic, that is our introduction part, where we will be looking into these three parts: acceptor, generator, and representator. But before that, the heading says as regular languages. See, if we talk about any kind of languages, okay, if we talk about any kind of languages, these languages actually depicts what? Actually depicts a set of inputs. And based on these inputs, we need to analyze and then we need to design a machine so that the machine which will generate the particular strings or particular transitions must accept these language. Okay, so initial level, we generally say that this is your regular language. Initial level, you can say initial level of languages is said to be regular languages. Then based on the demerits of the machine, we have optimized the machines, and then the languages actually changes. We will come across with that particular concept in the third unit, but properly I will let you know about regular languages. We will be discussing about regular languages in this unit. So definitely I will describe you the hierarchy of these languages. So the machine which generally accepts, okay, the machine which generally accepts this set of languages are said to be what? Finite automata. And this finite automata can be what? Can be finite automata with output, or it can be what? Finite automata without output. I hope this is what the general hierarchy of assigning this or accepting a language. Now come across with these particular 3 points. Here says that regular languages can be described or can be divided into three categories. One is your acceptor, one is your generator, and the other one is a representator. So acceptors are nothing but the machine that you are going to design. So in the case of regular languages, what is the acceptor? The acceptor is nothing but this finite automata, correct? So I hope it is clear now. Next point is generator. Generator means the particular concept which will try to generate the strings, and based on generation of the strings, these acceptor or machine will accept that particular strings. So here in the case of regular languages, the generator are regular grammars, or in simple form we can say grammars. And these grammars are the one which will produce or which will generate the strings from the given language. We will check this particular concept in unit number 3 in a very good way. Then next concept comes is representator. Definitely we have tried to understand the language. Based on that, we have designed a machine which will accept the language strings, and then we have tried to get a grammar which will generate the strings. And then there is another way of representing those strings is known as regular expressions, and which is the hot topic of today's session and also in unit number 2. So these regular expressions are the one which will help you to represent, that is the name of representator, represent a particular regular languages in the form of strings. And whenever we say expression, it comprises of two things. One is your operator, which will operate, and where it will, whom it will operate over the operands. I hope these are the two things that is very important while discussing an expression. Okay, now let's check it out. What is the meaning of regular expression? So regular expressions, the language accepted by finite automata can be easily described by simple expression or can be easily represented by simple expression, which is known as your regular expression. Okay, it is the most effective way to represent any language. Yes, I will, this particular point will be much more clear when we will try to do certain language equations. Okay, next third point is says that a regular expression can also be described as a sequence of pattern that defines a string. That means it will define a particular set of operands in the form of strings. Okay, I have told you, right? Two things in expression, operator and operands. These operands will be in the form of a strings, and operator I will discuss properly. Next comes regular expressions are used to match character combinations in strings. Wherever strings are there, from their strings we need to match the character combination, and that can be easily done with the help of regular expression. That is one kind of application for this regular expression. Next, string searching algorithm. String searching algorithm is also based on the basics of regular expression. So basically we can say that these are the two applications for regular expressions. Okay, now let's check how we can understand this regular expression, how we can utilize this regular expression in order to represent the strings, in order to designate a finite automata. Okay, and then we will try to get back to these applications, or you can remember these applications later on. Now come across with the third slide, where we will be trying to discuss the important part, that is operator. Operands are nothing but the strings. Operators now we will be going to discuss. So basically there contain three operators: union, concatenation, and clean closure. Okay, union is represented by plus. I think I have represented over here. Concatenation with dot, then clean closure with the help of this asterisk. So these are the three operators that we are going to discuss, and we will try to understand that if I put an expression by using plus, how it will be resemble with the finite automata. Okay, sometimes it becomes easy for getting an expression from that expression to get a particular finite automata. You will be coming across with these points. Next comes some of the special operators. Okay, these special operators actually it a to the power clean closure and a to the power positive closure. Actually, clean closure starts from the range of 0, 1, 2, ... till infinity. And if we talk about plus, it starts from 1, 2, ... till infinity. So these are the two ranges of clean closure, and this is said to be positive closure. We have seen in unit number 1. Okay. And whenever we say a to the power 0, a to the power 0 means what? 1. And here 1 is represented by epsilon. 1 is represented by epsilon and 0 is represented by phi. So we will try to look into this point very clearly. Okay. Actually, this representation helps you in understanding a lot of basic identities in regular expressions. Therefore, a to the power 1 will be what? Single a to the power 2, double a to the power 3. Now, only the difference in a to the power clean closure and a to the power positive closure is that this epsilon will not be present in this case. So therefore, I can simply write as A dot A to the power clean closure. So this is a very good example where all the basic operators are being shown, plus union dot concatenation clean closure. Okay. So these are the basic operators. We will try to look into these operators in a proper way. Okay. Now here are some of the primitive regular expressions we have mentioned over here. Phi is a regular expression represented by the language. This one means what? No strings are present, nothing. Only that we are having an initial state and nothing else, because we cannot declare that as a final state, as because no strings will be accepted by the machine. So it is just a null and void case. Then epsilon is represented by a regular expression, and this is represented in this particular format. If we talk about a single a which belongs to a set of integers, then this a will be represented in this format. Next, R1 plus R2. R1 and R2 are two different regular expressions, and they are being put together by the union operator. Same goes with concatenation operator, and same goes with clean closure. So these are some of the basic primitive expressions. Okay. Now let's start off with the examples how to represent a regular language in the form of expression. Okay. Let's check it out one by one. So the example number 1 says find the regular expression whose length is equals to 2. Whose length is equals to 2. Now whenever we say length is equals to 2, I think during the design of DFA we have discussed this language, which is the primitive language, correct? There we have tried to see that if the alphabet is given by 2 strings, then alphabet to the power 2 will define what? Length is equals to 2. And this means what? Correct, where concatenation operator comes. Now this means what? And if we try to merge both of them in an ordered pair, then it will be what? A, B, B, A, B, B. This is what the concatenation is all about. Therefore, the language of this particular given condition, that is length is equals to 2, will be what? A, B, B, A, B, B, which has been mentioned over here. See, I have mentioned over here over the input alphabet. Now what I have to do, I have to put this particular set of strings. These are one particular set of strings we are having in this particular expression. We need to put it into expression. What is the best operator to do this? Union. We need to merge all the things, right? So if you have to merge all the things, we have then see A plus AB plus BA plus BB. Then what is the basic thing that we need to do? We need to just use the mathematics. That is how we simplify our expression. So I have taken A common, then it becomes A into A plus B. Then I have taken from this particular point B common, then I have taken B A plus B. If I simplify, then it becomes A plus B into A plus B. Now, whenever we say length is equals to 2, I got how many times? A plus B into A plus B. So this becomes a very basic regular expression. Why? Because here we generally try to look into this particular concept A plus B and A plus B. Okay. Now I will be just going back and I will just show you one thing over here. Here, if we try to put any kind of expressions, A plus B, actually this means what? We are having an initial state, we are having another state, and we are having one transition for A and another transition for B. So this is actually the diagrammatic representation of A plus B. If we talk about A dot B, this will be learning in the next video. Then it will be A will be one transition followed by B another transition. A dot B means two different transitions we are concatenating together. Union means what? A and B are going in the same direction from one state to another state, and that's why we put them in the union state. Therefore, if we look into this particular expression, we can say that this A and B are in the same format and this A and B are in the same format. That means whenever we say length is equals to 1, that means what? Length is equals to 1 means what? Single A, single B. That's why it is said to be A plus B. If we look into this particular diagram, a single A is going on and single B. If we take this as a final state, then language will be what? Only A and B. Am I correct? These will be the two strings that is possible. How it is represented? A plus B. Therefore, this is nothing but what? Length is equals to 1. If I have to increase this length, A plus B into A plus B. Then if I have to increase length equals to 3, then it will become what? If length is equals to 3, then it will be becoming what? A plus B into A plus B into A plus B. If length is equals to 4, then it will be becoming what? A plus B, A plus B, A plus B into A plus B, and this will keep on going. So the best way in an expression to find out what is the length, just look into this pattern. Okay, so this is how you need to represent a particular language into an expression. Okay, let's go into the next question. It says length is at least 2. That means length should be at least minimum 2. After that, it can be n number of times. That means it is an infinite language. So the language has been given AB, BB. This is what? Length is equals to 2. After that, it is length equals to 3, and it will keep on going. So as my knowledge, I know length is equals to 2. What is the basic length equals to 2 expression? It is A plus B into A plus B. So at least 2. So minimum I got as 2. After that, it can be n number. So can I take A plus B? And do I have an n number of time that I will be writing the entire expression? I won't be writing, right? What I will be doing is that I will just put over here as clean closure. Now we know clean closure ranges from what? 0, 1, 2, ... up till infinity, and this power will help you out to find out the entire expression until it becomes infinite. Correct? Now, if I say asterisk equals to 0, then this part becomes 1. Then what is the length? 2. If asterisk equals to 1, then length will be what? 1, 2, 3. If asterisk equals to 2, then it becomes 1, 2, 3, 4. Now it will keep on going depending on the value of asterisk. So this is the final expression I have also analyzed over here. So in your examination, don't simply write A plus B into A plus B equals to length. First, you need to showcase this particular steps. This is your preliminary steps. I have skipped over here in order to make you understand a little bit fast. But in your examination, while writing A plus B and A plus B, how did you got it? You need to mention these steps in a proper way. Clear? So this is your second question. Third question says that length is at most 2. At most 2 means maximum to maximum 2. So that means the length will comprise what? The length will comprise 0, 1 and 2. So it is a finite language, maximum to maximum 2. Now I know what is the length equals to 0. Length equals to 0 means epsilon, correct? Length equals to 1 means what? A and B. Length equals to 2 means what? A, AB, BA, BB. Now these are the lengths that I already know. I just need to do what? Union operation. So therefore, regular expression will be what? Epsilon plus A plus B plus AA plus AB plus BA plus BB. Okay. Now this is your regular expression. Now I will try to simplify it. Okay, I will try to simplify it. A plus B, and from this entire expression, can I write down like this? A plus B into A plus B. I have done this time, this particular scenario in question number 1 also. Correct? The same way you can do it. Now what I can do, I can take some or the other. If I take A plus B as common, suppose I take epsilon plus A plus B, this as a common. Okay, this entirely as a common. Then what it will be? A plus B overall into epsilon. Epsilon stands for what? Epsilon stands for 1. So A plus B into 1 means A plus B only. Plus A plus B. I hope it is clear now. Why A plus B? Because this I have taken already a common. Correct? And A plus B, if I have taken common, then this, for this particular part, it will be epsilon. Because A plus B into 1, A plus B, plus A plus B into A plus B. If we expand this expression. So this is how we can simplify a particular expression, and I hope this language is also clear to you all. Okay. Now next comes to question number 4. It says find a regular expression whose length is even. That means the length will be what? Length will range from 0, 2, 4, 6 and so on, right? Length is even. That means I know this particular primitive language whose length is 2, right? I know this. So therefore regular expression will be what? A plus B into A plus B. I know this, right? This is length equals to 2. I need to increase this. I need to make it double. What do? We do a power, right? So I will do overall power. If I take asterisk C, if I take asterisk equals to 0, then it will become the entire expression as epsilon, which is length equals to 0. If asterisk equals to 1, then length will be what? 2. If asterisk equals to 2, then length will be 2 and 2, that is 4. Correct? If asterisk equals to 3, then length will be what? 2, 2, 2, 6. That is what it is coming. So therefore, this particular expression will give you all possible strings that comprises of length is equals to even. Clear? Now come across with example number 5. It says that whose length is equals to odd. So length will be what? The length will comprise of 1, 3, 5, 7 and so on. Correct? So that means what? If I look into this particular length, I know 2. Length I know 2, right? This already I have done. A plus B into A plus B I know. Length I know, right? Now what I can do, this is actually length equals to 2, but I want length equals to 1. So can I take one more A plus B over here and put entirely over as a power? So this becomes what? Asterisk equals to 0 means what? This will become as epsilon and this will be single 1. So length equals to 1, we got it. If epsilon equals to asterisk equals to 1, then this will become A plus B into A plus B into A plus B. Length will be what? 3. Correct? If asterisk equals to 0, then this will become what? Epsilon. So therefore regular expression will be what? A plus B, which is nothing but length equals to 1. If asterisk equals to 1, then the regular expression will be what? A plus B into A plus B into A plus B. If asterisk equals to 2, then it will be 4 and 1, 5. If asterisk equals to 3, then it will be 6 and 1, 7. So it will keep on going, and this will give you a very, very good example for finding out all the length which is exactly odd. Okay. Let's go to example number 6. Example number 6 says that whose length is divisible by 3. I hope this will be clear. Example number 7 will be very much clear to you all, because this you can do it on your own. Look at example number 6 whose length is divisible by 3. That means, see, divisible by 3 means what? Length will comprises of what? 0, 3, 6, 9 and so on, which is the divisibility by 3, and also as well as multiples of 3. Both are same. Correct? So 0 I know, so and 3 also I know right now. So what I can do? So length 3 I know, right? This is your length of 3. So if I take over here as a asterisk, can it work? Asterisk equals to 0, then it will be epsilon. Asterisk equals to 1, then it will be 3. Asterisk equals to 2, then it will be 6. Asterisk equals to 3, it will be 9. Then it will keep on going. So this is a perfect way of working the regular expression. Now look into example number 7. It says where number of A's is exactly 2. Number of A is exactly 2, but input strings are given as 2, A and B. Number of A is exactly 2. So I know, see, number of A is exactly 2. So A why I have done like this, see. First I have taken A, 2A, exactly 2 I have got it. It can be possible that in the entire string B can be can be initiating, or B can be n number of times. Correct? It can be possible that B can be in between A and both the A's. It can be possible that B can end with the string. So this is a perfect regular expression for looking into this. If its number of A is exactly 3, then it will be A. In between that B can come, right? And last also B can come. And B can be n number of times. It depends. So this is how we can do it. This is actually number of A exactly 3. And this is number of A exactly 2. Now let's go with the last 3 questions. Starts with A. starts with A. It's very simple. See, starts with A and input symbols are A and B. Starts with A. I have started with A. Okay, can it end with A and B? Any possible combinations of A and B? Yes. So what I can do, A plus B whole to the power clean closure. A plus B means what? A and B. See, both A and B are coming into the same direction and it is a self loop, that is nothing but clean closure. So starting with A, after that it can be any possible combination of A and B. So if you look into example number 9, it says ends with B. So starting can be any possible combination of A and B and ends with B. I hope it is clear now. Starting with A, ending with B. Then next, you try to do question number 10 on your own, because starting and ending with different symbols. See, starting, you can pause the video, you can try on your own. Starting and ending with different symbols. If we start with A, can it end with n number of any possible combinations of A and B? Yes. So I can do A and B. So starting with A and ending with B, can it be done? Yes. Starting with A, in between that any possible combinations of A and B, done. Then ending with B. It may be possible that it can start with B and it can end with A. Can it be possible? This also it can be possible. Now I need what? Starting and ending with different symbols. So starting and ending with different symbols, all are possible. Therefore, what I will do? I will just put a plus operator in between that. So I am trying to union these two concepts, and therefore the final expression will be what? The final expression will be A plus B whole to the power clean closure B plus B, A plus B whole to the power clean closure. So this is the final expression. Got it? So this is all about your total 10 questions that we have tried to do, how a language can be represented into a regular language, regular expression. So in the next video, we will come across with one more interesting topic related to this particular concept. So thank you for watching this video.